What's the smallest measurement you've used on a ruler that's in the English system?
I would say some fraction of an inch.
Right. So inch, half inch, quarter inch, eighth inch, 16th inch. Right. So, and usually those get down to 16ths of an inch, right? Or, and if you're using the metric system, down to millimeters. Well, that's how good your knowledge is of the length of that object, is down to whatever that smallest increment is. And we can cut hair, splice hairs about whether it's half of that or a third of that or whatever. But it's limited by your measuring device. So that's one kind of uncertainty in science, right? The other kind of uncertainty is a Gaussian distribution, right? So probabilistic. If I'm measuring the position of a star or measuring position something that, the precision of my ruler is really good, but there's other things going on, whether it's like my eye moving back and forth or other things. If I measure it 4 or 5 times, I'm going to get 4 or 5 different answers. And so it's somewhere in that circle then of it's somewhere in there. So then you've got that kind of uncertainty. Oftentimes we're trying to knock down that uncertainty level to smaller and smaller and smaller chunks.
Right. It's sort of like how Richard Feynman says that anyone who claims to understand quantum mechanics has just demonstrated that they don't understand quantum mechanics. But of course, the way Richard Feynman doesn't understand quantum mechanics is way different from how I don't understand quantum mechanics.
The other, mythical story about that is Einstein. A woman is at a party and a woman walks up to him and they're chatting and she says, "Well, I always had problems with mathematics." And he said, "Believe me, madam, your problems with mathematics pale in comparison to mine."
I understand. Perhaps the most famously uncertain person in history is Werner Heisenberg. Could you tell us a little bit about Heisenberg's uncertainty?
Yet another deeper level of uncertainty. It's an extension of the measurement uncertainty, but it tells you what the limits are. What the Heisenberg uncertainty principle says is, I can know where it is really well, but I have no idea where it's going, or I can know where it's going really well, but I have no idea where it is.
Well, part of the issue is that in order to measure something, to see it, you have to put some sort of light on it. And if it is small enough, the photons that you use to illuminate that thing disrupts its momentum, which is why you can't know the two at the same time.
The way I like to think about that is that you've got two objects that are like two tall, thin cylinders, right? Like two thin chess pieces. And you're trying to measure the distance between them. And you've got a very clumsy ruler that you're doing. And you try and get it in between, and then you start knocking them around. And you know that the ruler can fit in between them, so you knew how far apart they were. But now you've knocked them around, right? And that's exactly it. Our light is this clumsy ruler that we're using that ends up putting energy into this device. You want to hear a Heisenberg joke?
Please.
Heisenberg gets pulled over for speeding, and the officer says, "Do you know how fast you were going?" And Heisenberg says, "No, I don't know how fast I was going." The officer says, "You were going 75 miles per hour." Heisenberg says, "Damn it, now I don't know where I am."
That is the finest Heisenberg joke I've ever heard.
Newton had this clockwork universe, this idea that if you knew exactly what the system was like at any given time, then he could tell you how it would be like in the future. The uncertainty principle sort of puts a pin in that balloon and deflates it some, saying, yeah, except the key is you can't know exactly what the system is like at any given time. It always is... there's some uncertainty either in the position or in the momentum or in both.
When I tell a story, one of the great gifts of ignorance is humility. And it would seem that for scientists, people like you, humility would come more easily because you are more precisely aware of what you don't know. That said, in my experience, physicists have a reputation for being among the least humble of scientists. Who was it who said that in science it is either physics or stamp collecting?
Yeah, right.
Yeah, I know I've said that before, and I know you don't like it, but
somebody said it. Yes, right. And so.
Is that an unfair thing to say, that physicists have a reputation for hubris? I mean, it's like what Murray Gell-Mann famously said in the 1960s, that quarks exist. The fact that experimentalists have not found them is not my problem.
I do think that some of the best scientists are humble, but they're also resilient. So they know that they're going to get things wrong. And they aren't, and then they're going to, okay, that's wrong. On to the next thing. Let's try something else, right? And so you keep trying different things because you know your first guess is not going to work out.
So on the one hand, science requires humility. On the other hand, to think that you could possibly understand the dark secrets of the universe and the mysteries of time and space, that takes a lot of nerve, dog.
You've got somebody like Einstein who's like, I am exploring the thoughts of God. Newton and Einstein are exploring the thoughts of God. It's like, oh, okay, fine, whatever. Most of the rest of us are trying to balance our checkbook as right.
Stephen Hawking said that I want to know whether if in making the universe God had any choice. Physicists are always talking about God. Does your appreciation of uncertainty bleed out into the rest of your life? Are you more tolerant and humble when listening to the political opinions of others, the uninformed knuckleheads around you?
My girlfriend will say no. Karen will say no.
All right. Well, the rabbis say, who is wise? The one who learns from every person.
I aspire to that, but I haven't achieved it yet.
So your comfort with uncertainty is limited to physics.
Yeah. Well, to science, certainly, yeah. I think one of our science communication issues is that this is not a well understood concept, or more to the point is easily exploited, that we've got uncertainty in science, right? So if you go to the National Weather Service, if they say that it's a 10% chance of rain tomorrow in your location, that means that 10% of the time, and then you go and measure that, 10% of the time it rains under those conditions. The Weather Channel never ever says that. It's either 0% or 20%. So they will always take anything above 0 and make it 20, and then they increase from there.
And why do they do that?
Because the consequences of it raining on little Johnny's outdoor birthday party are so bad that if you say it's a 5% chance, and people's perception of percentages is poor, right? Then you say it's a 5% chance that it'll rain tomorrow, they'll plan Johnny's birthday party outside, and then they'll be mad at you for, because there's no perception of like, well, this was a very rare occurrence. We said there's a very low possibility, but there is a possibility. But when you actually make the measurement,
right,
it happened, right? There's 100% chance of whatever the weather was yesterday that's what it was.
Yeah.
Right?
Oh, that's kind of fun.
And that's because the weather.com, the Weather Channel, is putting out a product, not reporting a fact, right? They're putting out a product for consumers to use.
So overestimating the probability of rain is a service. They do that as a service to us.
In some ways, yes. It's certainly
right, because we check the rain because we want to know what is going to happen on the day of Johnny's big party. A friend of mine, for example, has a stage 4 stomach cancer. And
I'm sorry to hear that.
And he had a 5% probability of surviving a year. And
Okay.
that was 8 years ago.
Okay.
So
Well,
when I heard 5% probability of surviving, he's dead. He's dead. You know, I flew out to California to say goodbye, but he's still around. So that 5% meant that he was part of that 5%. He did live. He was that statistical, not even anomaly. He was part of that 5% that existed in the probability range that his doctors were telling him about. I get overswayed often by numbers that are really big or really small, assuming that which is most probable is virtually inevitable, which is not the case, of course. But as somebody said, since this is our joke session, the race may not go to the swift, nor the contest to the strong, but that's the way to bet.
Right. Yeah.
What I take away from this discussion is that, yes, we are doomed to massive ignorance, but at any given time, we can reduce it. We can always learn something to be a little less catastrophically ignorant. and that will ultimately have to do. It's as good as it's going to get.